Hello, and welcome to Cicada Code. This semester we were asked to look at a section of Peterson Avenue in Chicago through the lens of ecology, with the focus on preparing for the arrival of Brood XIII of the periodical cicada. First, we'll take a look at a map that shows the ecoregions of the eastern United States. Overlaid onto this map is major populated areas, as well as all of the periodical cicada broods. Highlighted in blue is Brood XIII. The cicada's life cycle starts when it hatches from its egg. It then drops to the ground and burrows into the soil, where it will remain for the next 17 years. During this time in the soil, it will grow and develop through a series of 5 instar stages, starting with instar 1, which begins when it hatches. When the young nymphs first burrow into the soil, they rely heavily on grass roots to survive. This is because it is readily available and easier to access for the small nymphs. As they grow and develop through the other instar stages, they begin to feed on more permanent tree roots. Once the 5th instar stage has developed, leading into the 17th year, it is then ready to emerge. But before that can happen, a few conditions have to be met. The soil 7 to 8 inches below the surface needs to reach a temperature of 64 degrees Fahrenheit. This can happen anywhere between April and June, depending on the latitude. Once this temperature is reached, on a late evening around dusk, they will begin to emerge. Once they emerge, they need to quickly find a vertical surface to begin the molting process. This would ideally be a tree. Once they have molted, they will enter what's called the teneral adult stage. This is where the new exoskeleton will start to darken and harden over the course of 4 to 6 days. This is also the point when their wings will develop and they can finally take flight. There are a few ways to tell males and females apart. The best one is the shrilling noise produced only by males. This incredible noise is produced by tymbals on the male's abdomen and is used to attract females for mating. Once the females are ready, they'll find a suitable branch for them to deposit eggs. They use what's called an ovipositor to deposit the eggs inside of the branch. After 6 to 10 weeks, the new nymphs will hatch and the process starts over again. But before they hatch, the mature adults will die off and decompose back into the soil. Next, we'll look at ecological impacts. First, we'll take a look at the underground ecology. As we previously learned, cicadas dig tunnels in the soil. These tunnels improve aeration, as well as infiltration of water into the soil. These tunnels improve soil characteristics and maximize ecological impact. Once cicadas do finally emerge, they provide a massive nutrient boost to the environment, specifically predators. This mass emergence is an ecological health marker for both the soil and the general environment. Cicadas can also be a natural tree pruner. When cicadas deposit eggs in weaker branches, it can kill them, boosting productivity in the tree. Finally, when the cicadas die off, they provide a massive nutrient boost to the soil. By far the biggest threat to cicadas is human development. Human development consumes both cicada habitat and food. Large gaps between their ecological requirements makes it difficult for them to survive and spread. One of the side effects of human development is soil compaction, which makes it difficult for nymphs to even make it into the soil to begin the life cycle. Another threat to cicadas is invasive species. These species compete for resources, often to devastating effect. To combat these issues, I'm planning to implement several design guidelines throughout the site. Some portions of the site don't require a huge design overhaul, but rather small maintenance changes. For example, this residential park area is quite green, but could benefit from several design changes. To benefit cicadas in this region, we need to implement new maintenance regimes. We need to reduce areas of land that require mowing, recycle on-site waste wood for mulch, as well as leave leaf debris throughout the year. Another practice that could be implemented is spacing out times between mowing intervals. We could also introduce more perennial woody shrubs and grasses. Next, we'll look at Peterson Avenue as a wildlife corridor. In its current state, one could see that it would be difficult for a cicada to traverse this landscape. There is little to no habitat for them. There are several things that can be done to mitigate these issues. For example, we could reduce the space between street trees to 12.5 feet and 18 feet for street trees and medians. We could also introduce more hardy street trees capable of withstanding the harsh conditions of the street. Along Peterson Avenue, we need to increase soil availability as well as food for the cicadas. Next, we'll look at a highly urbanized area. Here you can see there's little to no vegetation. There is simply no habitat for the cicadas in this setting. In this area of Peterson Avenue, there was only one living tree. To mitigate this issue, we need to implement major hardscape overhaul. We need to increase permeable surfaces throughout the site. To do this, we need to turn all available real estate into planting beds, such as medians, parking lanes, as well as wide sidewalks. We could also implement permeable pavers in tandem with trees to maximize soil area. With these guidelines in mind, one could begin to imagine a new Peterson Avenue.